A star so dense, one sugar cube of it would weigh as much as a mountain. What if I told you, there's a star smaller than your city, but heavier than our sun? A star so dense, one sugar cube of it would weigh as much as a mountain. A star that spins hundreds of times every second, sending invisible beams of light across the galaxy like a cosmic lighthouse. Would you believe me, or would you think I was making up a bedtime story? Well, friend, this isn't a story. This is real, and today, we're going to visit one. Welcome, space explorers. I'm so glad you're here with me today. Right now, we're floating about 4,000 light-years from Earth. That means the light we see left this star when ancient Egyptians were building their very first pyramids. And what we're looking at is called a neutron star. Neutron star. Now, you might be thinking, I've heard of stars before. The sun is a star. And you're right, but neutron stars are stars that have finished their lives and turned into something completely different. Something strange, something that breaks the rules of normal matter. Imagine taking something as big as our sun, so huge that 1,000,000 Earths could fit inside, and squishing it down until it's only 20 kilometers across. That's about the size of a small city. Like, you could drive across it in 20 minutes. How is that even possible? What happens to all that stuff? And why does it spin so fast? Well, that's exactly what we're going to discover. So grab your imaginary space helmet, hold on to your curiosity, and let's dive into the most extreme object in the universe. To understand neutron stars, we need to travel back in time. Not just a little bit, millions of years. Once upon a time, our neutron star was a normal star. A big one, maybe 20 times heavier than our sun. It burned bright and hot, shining with beautiful orange and blue light, just like other stars you see in the night sky. But this star had a problem. It was running out of fuel. Stars are like cosmic campfires. They burn hydrogen, that's a special gas, and turn it into energy and light. But eventually, they run out of hydrogen. Then they burn helium, then carbon. They keep burning heavier and heavier fuels, like someone using up all the small sticks before throwing on the big logs. Finally, this giant star reached iron. And iron is different. Iron doesn't give energy when it burns, it takes energy. It's like trying to start a fire with wet wood. The fire goes out. When that happened, the star couldn't hold itself up anymore. All that mass, all that weight, came crashing down toward the center. We're talking about something heavier than our sun, falling inward at incredible speed. But then, bounce, the center of the star was so tightly packed that it couldn't squeeze any smaller. It was like dropping a basketball onto a hard floor. Everything hit the center and exploded back outward. This explosion is called a supernova. It's one of the brightest events in the universe. For a few weeks, this dying star shone brighter than its entire galaxy combined. Brighter than billions of stars put together. And what was left behind, at the very center of that explosion? A tiny, super-dense ball of neutrons. Our neutron star was born. Space explorers, I need you to use your imagination for a moment. Really use it. Imagine you have an empty teaspoon. You know, the kind you use to stir hot chocolate. Now imagine I could scoop up a piece of neutron star with that spoon. Just a tiny spoonful. How heavy do you think that would be? As heavy as a car. Heavier. As heavy as an elephant. Heavier. As heavy as a house. Still heavier. That 1 teaspoon of neutron star would weigh about 1 billion tons. That's as heavy as a mountain. A big mountain, Mount Everest heavy. How is that possible? Well, remember how the neutron star was born. Everything got squeezed down so tight that atoms couldn't stay atoms anymore. Let me explain atoms simply. Everything around you, your chair, your hand, the air, is made of atoms. Atoms are tiny building blocks, too small to see, and atoms are mostly empty space. If an atom was the size of a football stadium, the actual stuff inside would be smaller than a single grain of sand sitting on the 50-yard line. But when the neutron star formed, all that empty space got squeezed out. It was like taking that entire football stadium and crushing it down until only the grain of sand remained. And then doing that to billions and billions of atoms, all crushed together. The result, matter so dense that a sugar cube-sized piece would sink right through the earth. It would fall through rock like rock falls through air. It would go straight to Earth's core and keep going. On a neutron star, gravity is 200 billion times stronger than on Earth. If you weighed 50 pounds here, you'd weigh 10 billion pounds there. You'd be squashed flatter than a pancake instantly. Good thing we're watching from our safe spaceship, right? Now, let's talk about something really cool. Remember those beams of light we saw sweeping around the neutron star? Those beams are like a lighthouse. And when a neutron star has these beams, we call it a pulsar. Pulsar, because it pulses. Here's what happens. Neutron stars spin incredibly fast. Some spin once every second. Some spin hundreds of times every second. That's faster than a blender. Faster than a washing machine on spin cycle. Faster than the engine of a race car. As they spin, they shoot out beams of light from their magnetic poles. That's the top and bottom of the star. These beams are made of radio waves, which are a type of invisible light. We can't see them with our eyes, but special telescopes can. Now, here's the amazing part. If one of those beams sweeps across Earth as the star spins, we detect a blip of light. Then, as the star keeps spinning, the beam comes around again, blip. And again, blip. It looks like the star is blinking at us. The first time scientists detected these regular blips in 1967, they didn't know what they were. They thought maybe aliens were trying to send us messages. They even named the first one, LGM-1, which stood for Little Green Men. But it wasn't aliens. It was just a neutron star, spinning like a top, beaming light across the galaxy. Still pretty amazing, though. Some pulsars spin so fast and so regularly that they're more accurate than atomic clocks. We can use them to measure time across the universe. Some scientists call them the universe's most perfect clocks. Now, I have to tell you about a special kind of neutron star that's so extreme, it almost sounds made up. It's called a magnetar. Magnetars are neutron stars with incredibly powerful magnetic fields. How powerful? Well, let me try to explain. If you have a small refrigerator magnet, it can stick to your fridge, right? That's a weak magnetic field. Earth has a magnetic field. That's what makes compasses point north. It's stronger than your fridge magnet, but still gentle enough that we don't notice it every day. Now, imagine a magnetic field so strong that it would erase every credit card on Earth from halfway to the moon. So strong that it would rip apart molecules, the tiny building blocks of everything, just by being near them. So strong that if you got within 600 miles of a magnetar, your body would dissolve because the magnetic field would pull the atoms out of your molecules. Don't worry, the closest magnetar is thousands of light years away. We're safe. Magnetars sometimes have starquakes, yes, like earthquakes but on stars. The crust of the magnetar cracks and shifts, releasing enormous bursts of energy. In 1/10 of a second, a magnetar can release more energy than our Sun produces in 250,000 years. These bursts are called giant flares, and they're some of the brightest events we can detect from outside our galaxy. Let's remember what we've learned today, because these ideas are big. First, neutron stars are born when giant stars explode as supernovas. They're city-sized but sun-heavy. Second, they're made of neutrons, particles packed so tight that a teaspoon weighs 1 billion tons. That's mountain-heavy. Third, many neutron stars are pulsars. They spin like lighthouses, sending beams of light across space. We can use them as cosmic clocks. And fourth, the most magnetic ones are called magnetars, and they have starquakes that release more energy than we can easily imagine. All of this comes from nature, from gravity, from the life and death of stars. No magic, just physics, pushed to extremes. Before we go, here are some mind-bending facts to share with your friends and family. Did you know, if two neutron stars collide, they create ripples in space itself, called gravitational waves, and they spray gold and platinum across the universe. Most of the gold on Earth, including the gold in jewelry, probably came from neutron star collisions billions of years ago. That ring your grandmother wears. Stardust. Neutron star stardust. Here's another one. Neutron stars can have mountains, but these mountains are tiny, only a few centimeters high. Remember how strong the gravity is. It smooths everything out. Even a mountain is smaller than a shoebox. And one more. Scientists think there might be something even stranger inside some neutron stars. Something called quark matter. We don't fully understand it yet. It might be a whole new state of matter that doesn't exist anywhere else in the universe. Neutron stars are still teaching us new things every year. They're like cosmic laboratories, showing us what happens when we push matter to its absolute limits. We've traveled across thousands of light years today. We've seen stars die and be reborn. We've held matter so dense it bends reality. We've watched cosmic lighthouses sweep their beams across the darkness. But here's what I hope you remember most. The universe is full of wonders we haven't discovered yet. Neutron stars were just a theory until 1967. Before that, nobody knew they existed. Now we study them, learn from them, and use them to understand the cosmos. Who knows what we'll discover next? Maybe you will be the one to find it. Maybe you'll grow up to be an astronomer, or an astronaut, or a scientist who solves the mysteries of quark matter. The universe is waiting for curious minds like yours. So keep looking up, keep asking questions, keep wondering. Because out there, in the spaces between stars, incredible things are happening. And now you know about one of the most incredible of all. Safe travels, Space Explorer. Until next time.